Today is September 18th. I just finished up installing the separation membranes into the 8x8 GSC or gas splitter cell, so it is a true gas splitter cell now. It is configured as a split. We have actually two cells in one here. This is the positive, and these are the negatives. They're tied together. Discharge here is the hydrogen, and it comes up into its isolation bubbler. This is all stainless steel now. There's no plastic other than fittings. I'm tired of being chased around the shop with flying plastic. The other side is this is a supply for the out of the oxygen side. It comes out of a separate tank. You've got two tanks here, and of course then this is the discharge here, which comes off the top of the cell here. Can't see it very well. Okay. And what I've got here temporarily, I use these rubber boots on top. If there's a backflash or something, don't be surprised. It'll actually remove these. It'll blow off. So a pretty good idea. You guys might want to look into doing something like this. And they also work on plastic or PVC or ABS because that's what they're really designed for. They're a sanitary cap, I think they call them out. But anyway, the oxygen is coming out through this tank and then going on down into this other vessel here, which actually is a dryer, but I'm using it as a bubbler right now to stabilize pressures. And the power supply, which right now we're putting 58.9 amps or so in there, 59 amps into it, into the cell, which I'm pushing it hard because I'm trying to see if I have any gas breaching, and so far so good. I haven't, and like I said, this is the first time I fired it up. I wanted to get a video of that and pass that info. This is a bubbler, a backflash bubbler, all stainless. I've tested it. That blew a lot of things into it and tried to get it to fail. There's a little pop-off valve here, and it works explicitly well. There's no issues with it, so I have no concerns. And that was at 6 liters a minute, and the reservoir was probably 50% full when I did that testing to see if I could get it to part. When I tested it, I did it in a vessel full of water, so if there was an eruption, it would be contained within that. There's a protocol for that. Anyway, that's the discharge coming out. Anyway, supply coming out of the hydrogen side, running down into the bubbler, and then out of the bubbler, down through a hose, and into a Bunsen burner. Now you can see that's a pretty large flame. I mean, there's a lot of hydrogen. And that is pure because you cannot run a Bunsen burner on hydroxy. It just won't happen. I've tried. It backflashes. It won't stabilize the flame. Pure hydrogen, there's no issues. And on the oxygen side, how I can test that is you take a match and you light it and get a good burning ember, or just take the match and reach down inside to the hydrogen side, or correction, the oxygen side. In this case, I'll show you what I'm talking about. You put the match right down inside here because oxygen's heavy and it's going to want to lay in here to a point. And you'll actually see the match flame increase. I'll see if I can do both here. I don't know if I can. So bear with me for a second here. I'll try to make this work out. I'm going to try to light a match here. Okay, I got the match lit. Okay. There's a match. Okay, now watch that flame. See how it increases? Okay, watch that again. See how it increases? See if we can get it to reignite. Nope, not this time. But at any rate, if there was hydrogen in that gas, it would have flashed. It would have popped, and there isn't. So it's good, clean separation. The next step, after I get this finalized, is I'll be taking an instrument, which is in work, and I'm going to be testing that hydrogen. And I'm going to do that to take a look at the energy levels and stuff and see through design if we can enhance things by changing the cell, changing electrolyte, adding catalyst, a number of variables. Excited also with the oxygen side, the same thing is take a look at the energy levels in that too. And it's easy to do once you get the correct instrumentation. So what I did is I'm in the process right now of building a spectrometer, and it's very crude right now, but it's in work, so I'll show you a little bit of that. Okay. I have a temporary cardboard cover, and I'm going to remove that. And what I've got here is, I don't know if you can see it very well, but this is a slit. It's one that I built, and it basically is two razor blades that slide back and forth, and then you can close it all the way down or open it up, and it provides a little gap right in here in this hole, and it's controlled by this wheel, open or closing it. Okay, and then it goes through a collimator lens. The beam actually, it's still full spectrum, but it comes through the beam, and then it comes off a mirror, and it's reflected to another mirror, and then from there it comes over here to where the grating is going to be mounted. And actually, this is, like I said, temporary. This is I can get right here. You can see kind of the little reflections in that's the grating. And this is not the best, but I have one on order that's a lot better. This is 13,500 lines per millimeter, which is a lot of lines. And the one I ordered in is 15,000 lines per millimeter. So should give us a good breakdown on spectrum. And this does okay. And it only actually they sent it to me for free because they sent me the wrong one the first go around. I got two of them. So I'm going to build a lens mount to protect that. But to get over here on the other side, I don't know if you can see that. That there is the optical slit, and you can see you can open it or you can close it. You can see this little gap right here. I'm opening it up. Now I'm going to close it. See? It narrows up. Okay, that's how that works. And what that does, it opens and closes the spectrum window. You can make very, very slight, precise lines for identifying spectra. And then on the other side of this is another little telescope, if you will. It's actually a collimator lens too, but focal length. And what the idea of this is when you look at real dim objects like astral star spectra, for example, the objects are pretty dim. So what you need to do is you kind of magnify them up, and that's the idea of this concept. And it magnifies the spectra, and I end up with a real good representation. And then I utilize this. This is a device, a Ross-Null device, where I use when I'm designing and testing telescope mirrors. I happen to have this on hand because of the Ross-Null tester, and I put this between the little telescope out front and the object that the gaseous flame or whatever, light bulb, candle, LED or whatever it may be. And it helps magnify that image a little more. So I'm still in work. I'm going to be adding some more optics to this. And then when it's all finalized, it'll be all packaged. There'll be a cover over this, or it'll be light proof. Otherwise, no outside lighting can come into play. And what you do is you set a camera right here by the grating, or a CD camera, or even a little device that you use for your on your laptop or your desktop for video conferencing, a little video, whatever they call them. Anyway, that can be mounted there and go into a laptop to collect the data. And then from there it goes through 3 different types of software to do the analyzing. And when you're all said and done, you can identify the elements, you can identify the intensity. There's a lot of information that you can acquire. So this will all be developed out, plan sets configured, and vendors sourcing for you guys who want to try building one of these. This is a little more complex. There are some stuff on the internet, some real basic things to give you an idea how it all works, and you can do it with a DVD or a CD to take a look at the spectra. In fact, you take a CD or DVD and you tip it up to the light and you move it correctly, and you'll see spectra. That's what we're doing, but I'm doing it a couple steps above that quality so we can actually get some numbers and analyze them. But Mike Powers and Dustin were interested, and I imagine a few others too. They haven't said anything, but that's basically what's going on with that. Very good piece of equipment. It's going to be real handy. But getting back to this, I'm pretty satisfied at this point. Like I said, that's a lot of gas, a lot of hydrogen, and if things progress, I'll probably be taking this unit here, and I'm going to be setting it up on to run a small engine on the just hydrogen side, kind of like what Ed McAllister did with that little four-stroke of his. Very similar process, and if I can get it operational, kind of experimentation. Hydroxy is awesome stuff. And I have no complaints. It does what it's kind of designed to do. But guys have been fighting instrumentation with computers and not seeing anything, any benefits from it because the computers are fighting them. And the idea of this is to give the experimenter the option to run one gas, just the hydrogen, a fuel, into the engine to see how it affects the system. And then if they decide to, they can take the oxygen component, the other side, and bring it into the gas stream too. You can do it through metering. You can put a little metering valve and just add a little bit of gas or a lot of gas to see how the computer responds. So it opens up a lot of more experimentation and a lot more control for the end user, because you have the objects or have the option now to run two gases or single gases. So I think there's some real benefits here. And of course, if a person chose to, once you develop the correct flow sheet downstream of this system here, of this guy here, all right, you could take this gas and you could compress it. And you could put it into a hydride tank. You could pump it into a propane tank for small, short-term usages. You could it's just endless. Use it for heating. Very, very stable. Very safe. Because hydrogen is so light, and it's such a small gas, it'll dissipate really fast. It won't lay on the floor like propane or natural gas does. And like with the hot water heaters, propane hot water heaters, flame out or something on the pilot light, fill the basement up with gas. I mean, they have instrumentation and sensors now, but if those fail, you got a bomb. This gas won't do that. It dissipates. It'll go right through your ceiling. So it's the next step, and I'm hoping everybody agrees with that, because we just need to continue working. That was the whole idea of this, is to options. And well, there it is. We got two models. We got a 5x5, that one I published before. Now we got this 8x8. And this one particular cell can easily be converted to a 24-volt cell. And you could utilize it for your bigger trucks. So, I mean, it's designed to run in at about 60 to 62 amps at a half of an amp per square inch of loading. But if you could push it, you could push it on up to 1 amp or so. And, gas output, okay, I tested it as a hydroxy cell, and I could easily produce 6 liters of gas at 65 amps. So we're doing really well with this cell. It's very efficient. Like I said, I posted it before, 81%, and then I tweaked it. And what I did on that change is I increased the port sizes here. The fitting sizes, they were 3/8, and I increased them to 1/2 inch. And by doing so, that opened up the cell to allow it to breathe, allow it to clear itself of gas. And my efficiency went from 81.24% up to 97%. And there were 6 readings. Some are a little lower than that, some are a little higher than that, but the average was 97%. Now that is very, very good for a cell of this type, especially because there is open porting. But the way the gaskets are designed is they seal, when they're pressed into this format, they seal those round portholes that go through the plates, and it reduces that parasitic loss. And so that's a good step forward too. Now, I know some of you are going to be argumentative, and that's fine. Let's, all I can say is replicate this, or the 6x6 or the 5.5 or the 8. Replicate it, test it, and you will see. If you follow the protocols, you'll see what I'm saying. So anyway, guys, I'm going to wrap it up here because I'm kind of rambling now. Besides that, I'm going to go have a beer and celebrate. And I'll talk to you guys later.